All right, so the next section is this introduction of what we are going to call the unit circle. And so we got to talk about two different terminologies of angles first, and then we will get to the nitty-gritty. Okay, so the first concept was the fact that we had just put an angle on a coordinate grid. And we said counterclockwise was a positive angle and clockwise was a negative angle. So there is this new term called coterminal angles. Well, the word co represents the sharing, and they are sharing a terminal angle. So what I'm looking at is if I have an angle that is 65 degrees, right? Here's my initial side. And if I were to graph the terminal side, it'd be a little past 45. So let's say kind of right there. This would be a positive 65-degree angle. Okay. But if there is another angle that shares that same orange, which is the terminal side, the only way that's possible is if I go the other direction. Okay. If I go the other direction, that's going to make that a negative angle. And so what do? We take 360 because that's the entire circle rotation, and we subtract that 65 off of it. And so the coterminal angle would be negative 295 degrees. Cool. Okay. Let's go to a reference angle. Okay. So a reference angle is an angle that is a positive acute angle formed by the terminal side and the closest x-axis. Okay. So for instance, if I have an x-axis term initial side right here, and I graph 225, let's say this is 90, that's 180, this is 270, so it's got to be somewhere kind of in the middle. Okay, so this is going to be my positive 225 degrees. Now, what I'm creating is the small acute angle that is in between this terminal side and the closest x-axis. So let's think for a second. If I continue going this direction, that x-axis is not as close as this x-axis. And so a reference angle is the angle that is created by that terminal side and the closest x-axis. Okay, so this is 180 degrees. This is 225. So the difference between the two would be 45. Okay, so 225 minus 180, this would be a 45-degree angle. It is acute because it's less than 90, and it is the angle difference between that 225 and the closest x-axis. Okay, let's go negative 310. So if I go negative 310, that's actually going to be a negative angle. So that means I'm going to go in this direction. There's negative 90, right? Negative 90, negative 180, negative 270, and then a little bit more. How much more? 40. Okay, good. So that's going to be right about here. So that is my negative 310. Now, the closest x-axis is going to be this one right here. So if I kept going, what would this angle be created that we created? This would be negative 360, right? If I went completely in the circle, this is negative 310, then the difference for that is a 50-degree angle. Okay, not too bad. Not too bad. Okay, cool. So let's chitty chat about some things from math too. Okay. And I hope to teach this to you live because it's much more entertaining and it makes more sense. But if you happen to miss a class that day, or we happen to not be this is just is what it is. Okay. So I want us to think back to math two. Okay. Do we remember, and this is an audible question that you can answer, do we remember Pythagorean theorem? Awesome. Okay. It's a squared plus b squared equals c squared. Okay. Great. Check. We got that. Do we remember the functions, the trig functions, sine, cosine, and tangent? Maybe, maybe not. Maybe you remember this. SOHCAHTOA. Maybe you remember that. Okay. What did that stand for? That stood for the sine of the angle is equal to the opposite over the hypotenuse. The cosine of the angle was equal to the adjacent, and we'll go over what this is in a second, hypotenuse. And TOA represented the tangent of the angle equals the opposite over the adjacent. And so what we were looking at was we were looking at the angle measure. So if I have this angle measure right here, this theta, what would be opposite of this particular angle? It'd be the opposite leg, which would be y. This would be the adjacent leg. X would be the adjacent leg. And then R would be our hypotenuse. Okay. So if I were to create an idea of what a trig function or a ratio would look like, then I could do the sine of theta, which would be opposite over hypotenuse, which would be the y over the radius, right? The radius of the circle. I mean, we're not talking about a circle yet, but keep thinking that. Okay. Cosine would be x over r. And then the tangent would be the opposite over adjacent, right? So if we thought about those things in reference to this math 2 concept, okay, then you're in a good place. Now, I want you to think about that we're going to introduce this new concept of there's going to be coordinates, okay? And so I want you to remember that if I go to the left a certain amount, left or right, that's going to be my x coordinate. If I go up a certain amount, that's going to be the y coordinate. So this is up slash down. This is left slash right. Okay. So I am still on a coordinate grid. Okay. Cool. So let's take that same concept with a trig function and talk about a trig ratio. Okay. There are those three common ones, and then there are three more. Okay, there are three more. Now, maybe we could, since you wrote it right here, I don't think we need to write it again, so that's kind of pointless for us to do that. But I do want to talk about the new functions. These are called reciprocal functions. And we know from our rationals unit that reciprocal means to flip. And so if I were to write out what the sine of theta would be, right, here's theta. The sine is the opposite over hypotenuse. So the sine of this particular angle would be A over C. The cosine would be B over C. And the tangent would be opposite over adjacent. So A over B. Okay. Now, reciprocal means to flip. So while we are putting this over like under 1, what we're doing is we're just flipping the ratio. So I want to introduce you to 3 new functions that you will see the further you get into pre-calc. You'll see them for the rest of this unit. and it'll be fine and dandy. Cosecant, which is abbreviated as CSC. Secant, which is abbreviated as SEC. And then cotangent, which is abbreviated COT, or you can call it COT, but it's not really COT, it's cotangent. So saying those words definitely is new. So we got secant, or we got cosecant, secant, and cotangent. So cosecant goes with sine, so it's the flipped version of sine. So this would be C over A. Secant goes with cosine, so this would be C over B, or the hypotenuse over adjacent. And then cotangent goes with tangent. That one's the only one that makes sense, okay? And that would be B over A. Okay, so we're going to do one really simple, number 9, just practicing flipping the, creating the ratios and flipping them over. Okay, so let's first find the hypotenuse. Okay, so the hypotenuse has got to be found by doing Pythagorean theorem. So these are my two legs. So I'd have 16 squared plus 30 squared equals, I don't know, squared. So 16 squared plus 30 squared equals 1156. And then I'm going to square root that. So I get the hypotenuse of 34. So my hypotenuse is 34. And now I can find the functions of, I can find all the trig function ratios, sorry, from theta. So remember, theta is down here. Okay, the opposite of theta is 16. So this would be 16 over 34. We could reduce it if we wanted. That would be 8/17, but we can leave it like that, or we can write it in because I feel bad if we don't. Okay, cosine would be adjacent over hypotenuse. So that would be 30 over 34, which would be 15/17. And then tangent would be opposite over adjacent. So that'd be 16 over 30. And that would be 8 over 15. Those would be the basic, already you know trig functions. Okay. If I'm finding the reciprocal functions, I am simply going to just flip all of these and write them. So this would be 17 over 8. That would be the cosecant of theta. 17 over 15 would be the secant of theta. And 15 over 8 would be the cotangent of theta. Okay, cool. All right, so before we get into the nitty-gritty, here's what I want you to do. Okay, I would like for you to do the Pythagorean theorem or these special right triangles. Okay, if you remember from special right triangles from Math 2, if you remember those sentences, I'm going to ask that you pause the video, see if you can remember it. If you need to Google it, that's fine too. But I would like for you to find the sides of all of these right triangles with the hypotenuse being 1. Okay, so I want you to pause the video and I want you to see if you can find out the leg values given that the hypotenuse is 1 on the following triangles, which is a 30, 60, 90, and a 45, 45, 90. Okay, so pause it right here and we'll be back together in a minute. Okay, so let's start with the 45, 45, 90 because the 45, 45, 90 triangle is an isosceles triangle, which means that when I find one leg, I will have also found the other leg. Okay, so maybe you remember that the leg is equal to the leg, and then the hypotenuse is equal to the leg times the square root of 2. Maybe you remember that, maybe you don't. It was a pretty big unit in chapter 2, in math 2. So if I know that the hypotenuse is 1, then the leg is x, I could solve for the x value, knowing that this would be the exact same thing for x and y. Okay, so I could divide by the square root of 2. I would get the leg would be equal to 1 over the square root of 2. And in math 2, you also talked about this concept called rationalizing the denominator. And so we cannot have a radical on the bottom. So in order to get rid of it, we have to multiply by the square root of 2 over the square root of 2, top and bottom. So the leg value is the square root of 2 over 2. Okay, because this right here is the square root of 4, which goes down to 2. So if one of the legs is the square root of 2 over 2, then both of the legs are the square root of 2 over 2. Okay, cool. The next sentences from the 30, 60, 90 are that the short leg is equal to x. The long leg is equal to x times the square root of 3. And the hypotenuse is equal to 2 times the short leg, or in this case, 2 times x. Okay. Now, again, if you don't remember this, there's a video on YouTube, I'm sure, that you can find in your own free time, or Khan Academy has those things too. But for the sake of all that is good and right in the world, we just need to move forward. So if I know that the hypotenuse is 1, this is the only formula that I can use. But I could find the short leg, and then the short leg is in the long leg formula as well. So if I divide by 2, I get that the short leg is equal to 1/2. Now, in this case, the short leg is the one that's across from the smallest angle. That is a property of triangles. So the short leg would be equal to 1/2, and then the long leg would be equal to 1/2 times the square root of 3. Now, we're not going to write 1/2 times square root of 3. We're going to make sure that we write it appropriately. So this would be the square root of 3 over 2. Now, my last triangle is exactly the same triangle, but my angles have changed. So now my long leg is right here, and then the short leg is the one kind of on the bottom. So the short leg is equal to 1/2, and the long leg is the square root of 3 over 2. Okay, so I'm going to pause the video right here because we're probably maxed at like 20, 25 minutes right here. And you are going to catch up in the next video to introduce how all of these triangles are incorporated within the unit circle. Okay, so I'll see you in the next video real quick.